Hi guys, welcome back. This is section 6-3 and this is going to be about pressure and volume relationship. And so we've talked a little bit about what all the properties are of gases. Now we're going to look at how they actually interact. So the pressure and volume relationship we're going to be talking about has to do with Boyle's law. Okay, and it has very relevant applications, especially in healthcare, because it explains how we breathe. So Boyle's law basically states that the pressure of a gas is inversely related or proportional to its volume. And so we're talking about P and V here, okay? So if I have a piston, okay, and we use a piston because I can kind of push it under pressure. Alright, and I can push this down, okay? I'm going to squeeze this gas because gas is what we call compressible, okay? Liquids aren't compressible, okay? And so you might have heard the term compressed gas in a big cylinder. Alright, so we can compress that gas, and when we push it, we are increasing the pressure we're putting on it. And when we do that, we can decrease the volume. Okay? Now, in order for this to happen, temperature and the amount that you have of the gas has to stay constant. Alright? And so, if I multiply P times V, it's always going to equal what's called a constant. Okay? And why that's important is, if I change anything, they're going to have to remain equal, and that gives me a way to solve for a P or a V just based on what I know about the system. So in this example, notice I start out with 4 liters and I squeeze it down to 2 liters. Well, in order to do that, I have to go from 1 atmosphere of pressure to 2 atmospheres of pressure. Alright, I doubled my pressure and I halved my volume. Okay, so that is the relationship. If I double my pressure, I half my volume. If I half my pressure, I double my volume. Okay, so it works both ways. So if my pressure is 8 atmospheres and there's 2 liters, then if I multiply those two together, I get 2 atmosphere liters, or 2 liter atmospheres. So if I went 4 atmospheres at 4 liters, I had 16 atmosphere liters. When I change that, if I only do 2 atmospheres, it's going to increase that to 8 liters because this number is going to be constant. So that's why we say Boyle's law as P1V1 is equal to P2V2 when T and N are held constant. So what that does is that lets us be able to calculate the changes in pressure if we know the original conditions and what the new volume is. Fun, right? Now, the reason this is important, as I said earlier, in healthcare is when you inhale air into the body, your lungs expand. And since you're increasing the volume in your lungs, what's happening to the pressure inside? It's decreasing. Okay? So the air flows towards the lower pressure. So as you fill your lungs up, the pressure drops, allowing you to pull more pressure in. Okay, does that make sense? When you exhale, you are decreasing the volume in the lungs, and so the pressure inside increases, and so the air is going to be pushed out. Okay? And that's a very simple concept. Don't try to overthink it. Just mull over that a little bit and just accept that for what it is, okay? So when we use this to solve problems, often we will be given 3 different things. We might be given 2 pressures and a volume, and then that'll allow us to actually rearrange some equations and solve for the second volume. Okay, so we can rearrange this. Now, some people like to go ahead and rearrange the formula before they do the problem. Other people like to plug the numbers in and then rearrange it. It is a personal thing. It just depends on what you like and what you would rather do. Okay? Neither way is more right or wrong. So we mentioned that we're going to use a barometer to measure the pressure, right? And we've got this atmospheric pressure. And so we're going to use this pressure-volume relationship to work some problems. Okay? So we're going to first make sure that we organize our data. And I call this step take inventory. Okay? So you organize your data, you take inventory. That is, okay, you see, I got P1 is this, V1 is this, etc. Then you rearrange the gas law equation to solve for the unknown. This is the math way to do it. If you don't like that way, then put your numbers in first and then rearrange it. There is nothing wrong with that, okay? Then you substitute the values in if that's the way you're going to do it. So, here's a problem for you. Freon 12, okay, and there's the formula, is used in refrigeration. What is the new volume? Okay, now here's our keywords. New volume. That means it's going to be V2 in our system. New, okay, of an 8-liter sample. That's V1. Initially, at the beginning, at a pressure P1 of 550, after its pressure is changed, okay, so we're changing it to P2, and we kept T and N constant. So the way they're telling you to do it is you take your inventory in initial and final. So you're initially at 550 millimeters of mercury at 8 liters. You are going to push on that and increase the pressure to 2200 millimeters of mercury. So the question is, what is the new volume going to be? We know it's inversely proportional, okay? So if we push harder, what's going to happen to the volume? It's going to go down because we're squeezing it. So our relationship of Boyle's law is P1V1 equals P2V2. And so all they've done is they have rearranged this formula to solve for V2. Okay? Now, this is basic algebra, but in order to get rid of, if you want V2 by itself, what do you have to do to both sides? You divide by P2. Okay, and then you got P2 over P2, which cancels it out, and that leaves you with V2 is equal to P1 times V1 divided by P2, which is what they have right here. Then you just go back to your inventory and you say, okay, V1 was 8 liters times P1 was 550 millimeters of mercury divided by 2200, which is P2. Okay, and then you multiply 8 times 550 equals, some of y'all have been having trouble with your calculator, so I strongly recommend that you say 8 times 550, get that number, and then divide by what's on the bottom, which is 2200. You should get 2 liters. Okay, and that's what we would expect. If we increased our pressure, our volume would go down. And you can kind of do like a reality check with it to say, okay, if your pressure went up and then your volume went up, you'd probably know you'd done something wrong. Okay, so here's our problem. A sample of oxygen gas has a volume of 12 liters at 600 millimeters of mercury. What is the new pressure when the volume changes to 36 liters? And T and N are constant. Okay, so I'm going to take inventory up here. My first volume was 12.0 liters, and it was at an initial pressure of 600 millimeters of mercury. Okay, now notice, I can use the millimeters of mercury and everything as long as my units are the same, because these are going to be proportional. Okay? So, what else do I know? I know that V2, we're changing it to 36.0 liters. And so it's, what is the new pressure? So I'm looking for P2. Okay, so I know that P1V1 equals P2V2. That's a pretty easy one to remember, right? All right, so then I plug in, and so, all right, now, if you were just going to solve for P, what would you do? You would have to get P by itself. I know this is, dragging some of y'all, but you can just fast forward me. You'd have to divide by V2 on both sides. That's how the V2 gets over here, because then the V2's cancel on this side, leaving you with P2, which is what we're looking for right there. Okay, so that rearranges to P2 equals P1 V1 over V2. So that is going to equal 12 liters. Sorry, I did the volume first. Sorry, don't shoot me. Times 600 millimeters of mercury, as long as I got the right one on the top and the bottom, right? Divided by V2, which is going to be 36 liters. Okay? And so P2 is going to equal 12 times 600 divided by 36, and I believe that is going to be 200 liters canceled, so I'm going to have 200 millimeters of mercury as my answer. Alright, let's see if we did it right. Organize, put it in, cancel your units, and we were correct. They got 200 millimeters of mercury as well. Sometimes I disagree with the book. Oh well. Alright, so here's a thinking learning check for you. For a cylinder containing helium gas, indicate if cylinder A or cylinder B represents the new volume for the following changes. Pressure decreases. Which one would show you pressure decreasing? And which one would show you pressure increasing? You can turn me off and think about it. Alright, if I'm pushing down with my piston, then I'm increasing my pressure, right? So that would be 2. If I'm decreasing from, and remember I started here like halfway, so I've decreased my pressure, okay, so my P is lower, then my volume is going to be higher. Okay? If a sample of helium gas has a volume of 12 milliliters and a pressure of 850 millimeters of mercury, what is the new volume if the pressure is changed to 425? Notice that the answers are in milliliters, so I can just leave it in milliliters. So I am given V1, 120 milliliters, P1, 850 milliliters. What is the new volume? Okay, what is it? Question mark. If I change the pressure to 425, sorry, that's millimeters of mercury. Millimeters of mercury. Okay, so I'm solving for V2. So, and I do this every time. I know y'all are going to want to try to switch gears and not do all these steps, but I strongly recommend that you do these steps. Alright, so P1V1 equals P2V2, and I'm solving for V2, so V2 is going to equal P1V1 over P2, P2, okay? And if you don't remember how I did that, just go back to the slide before this, okay? So now I'm going to plug in V2 equals 850 millimeters of mercury times 120 milliliters divided by 425 milliliters, and 850 times 120 is 102,000 divided by 425 is 240 is what I got. V2 equals 240. Let's see. So look, did y'all catch me? I tried to write that again. It's milliliters of mercury when I'm talking about pressure, because those cancel. And I knew that because they had to cancel, and I went back and checked. So I'm left with milliliters, which is what I'm supposed to have. And here's the long way. A sample of helium gas in a balloon has a volume of 6.4 liters at a pressure of 0.7 atmospheres. At 1.4 atmospheres is the new volume represented by A, B, or C. Okay, so if I started out at 0.7. Sorry. Alright, so I started out at 0.7 with 6.4 liters, and I'm going to 1.4 atmospheres. So if I've increased the pressure, so would my volume increase or decrease? If this is my initial volume right here, and I doubled the pressure, what would happen to the volume? You are right if you picked A, because you would decrease the volume by half, right? Very good. And that's it. We're done with this section. We're going to continue our discussion of how to work problems with these different properties of gases, so stay tuned. I'll see you in a few.